When we're using a multimeter to measure low values of resistance, one of the errors you will encounter is the resistance of the test lead wires themselves. And I'll show you. If we set this to ohms, this is a Fluke 87.5 multimeter, set that to ohms and we connect these two together, you'll see that we don't read exactly 0 ohms. You read, in this case, 0.2, 0.1. And that is the resistance of the lead wires themselves, the connection at the end, and also the banana jacks right here. If there's any dirt or corrosion, all that comes into effect and contributes to this added resistance. If we're doing a precision measurement where we want to make sure we're not even off by that much, there's a neat feature available on the Fluke meters called relative. And some other brands of meters have this as well. It's kind of like the tare button on a scale. If you want to measure a container full of something, you set the empty container on the scale first, you push the tare button, and that zeroes the scale to the weight of the container. Then you're only measuring what you put in the container. Same thing here. Think of this as a tare button. When I push this button, it's going to zero that display, so I will only read resistance above and beyond what I already have in my test leads. So watch this. Hit the relative button, I get the delta symbol, the relative symbol shows up, and now it says 0. Now I'm ready to read resistance. So if I connect this to a resistor network on my board, I'm reading 117.6 ohms, and that is only the resistance of the network. I am not including the wire resistance because I have zeroed that out using the relative function.